Hi everyone, this is your G. Today we are going to talk about a topic on basic organic chemistry, and that is hybridization and shapes of molecule. This is the outline of this today's discussion. We will talk on the various concept of hybridization and also how this concept came, how this the types of hybridization, importance of it, and how when it fails, and also we'll discuss the shape of molecules, how we can predict the shape of a molecule, and also when hybridization or VSEPR theory important. We will discuss the planarity of molecules and how hybridization helps to determine the planarity and also the different factors which favors the molecular planarity, and then we will discuss few previous year questions on this topic. Now, what is hybridization? See, in our everyday life, we have 8 different vegetables and grains. Those are hybrid. Generally, how they made? When genetically two different species are mixed together, then a new type of species are originated called the hybrid species. Similarly, here the steel is a hybrid materials which form or made by using iron and carbon, and there are so many materials or species in our everyday life. Those are hybrid in nature. Similarly in chemistry also we have hybridization concept. So we have element, and those are composed of multiple atoms, and again atoms have orbitals. These atomic orbitals are defined like s orbitals, p orbitals, and also d orbitals. These are different shapes, but these shapes are come from quantum mechanical calculations. But yet the shapes is important because it is the home for electron, and which electron in the present in the orbital are responsible for chemical bond formation. The same way, hybridization in chemistry happens when the pure atomic orbitals are mixed together to form a new orbital called hybrid orbital. Here in this cases, the s orbital when mixed with a 1p orbital, it will form the sp hybrid orbital. 1s2p, this then mixing gives the 3 new sp2 hybrid orbital. S and 3p orbital mixing give sp3 hybrid orbital. S, 2p and d after mixing give dsp2 or sp2d, and S to 3p and d mixing give dsp3 or sp3d. Now, here is one question for you. Why I have used here DSP2 or SP22, SP2D? Why not the only one? So, please comment in the comment section. And as this pure orbital after mixing gives hybrid orbital, these pure orbital are of different energy, but not in mind. Keep in mind that hybrid orbitals each have the identical energy and identical shape. As we are talking about the organic compound, which mainly the chemistry of carbon, so it has only sp orbital. So we will further talk on only these three sp, sp2 and sp3 hybridization in next few sections. Now, how this concept came? Let's see here, two atoms are connected or bind together to form a molecule. We could see here that atom binded by a bond. This can be a chemical bond, either ionic, covalent or metallic. But in case of organic molecules, as they are mainly composed of carbon and hydrogen, so this bond can be a covalent bond, because covalent bond is formed by the atoms of similar electronegativity. We could see that carbon electronegativity nearly 2.55 and hydrogen is nearly 2. Let's have a general discussion, like here two peoples of similar strength, like either social, economical or physical, but their strength are insufficient to a particular task. If they mutually get agreed and make a friendship, then they totally can use their strength for a required task and get benefited equally. So the same way, the atom use their valence electron for their stability when they form a bond. Like here, if we consider this is carbon and hydrogen, when they forming bond and sharing their electron mutually, they get stabilized, and at the same time they target to close to the inert get electronic configuration like 8. So it is called octet. The same way here, if carbon-carbon bond is formed, here also they mutually share 2 electrons. Here this consider this is a bond and sharing 2 electrons. And we could see here this carbon gets fill up octet and other carbon also close to fill up their octet. So this formation of bond by using valence electron called the valence bond theory, or in short it is VBT. So core principle of VBT is the orbital overlap and electron pairing. We could see here this is the carbon ground state electronic configuration, and where this s orbital and p orbital contains the electron. Here hydrogen s orbital contains electron. This is the s orbital and these are the p orbital. Now how these orbital get overlap? See, the two way this orbital overlap can happen, either the head-on overlap or the lateral overlap. Let's see how this head-on overlap happen. So this head-on overlap generates a bond, covalent bond called sigma bond, here SS. Now here we could see PP head-on overlap and this SP head-on overlap gives the sigma bond. And when lateral overlap of PP orbital happen, then it generates a pi bond. Now covalent bond form even from pure orbital overlap. See here, the hydrogen atom having 1s and 1s orbital both get overlap, give the H2 molecules, electron get paired up and sigma bond form. In case of fluorine molecule, so two fluorine atom using their p orbital electron 1 1, they can get shared the electron, so electron get paired up at the same time and this FF sigma bond form. Interestingly, the sigma bond are stronger than the pi bond, because in case of in case of sigma bond formation, there is a head-on overlap happen. So there is head-on overlap give the effective overlap. Area overlap is more. In case of lateral overlap, which gives the pi bond, we could see that the overlap area is less. This is not effective like the head-on overlap. So that's why the sigma bond is stronger. Here is one question for you. So why p and d orbitals forms the pi bond? Why not s orbital? Please comment it on the comment section. We talk on covalent bond formation. Even the pure orbital can form sigma bond, but yet could not find out how this hybridization concept came. History starts here. In 1916, scientist Lewis demonstrated bond is a pair of electrons. Then in 1919, scientist Langmuir says it is a covalent bond because they share their electron. In 1927, This covalent bond explained by quantum mechanical calculation by scientists Hitler and London, and then in 1928 scientist Pauling discovered that valence band theory, that is VBT. So from this VBT it explains the formations of many bonds, but it cannot explain the formation of methane. That is strange. What it cannot explain, it cannot explain why this carbon atom make 4 bonds in methane, and because we could see that carbon ground state electronic configuration where the p orbital has only 2 valence unpaired electron. So 2 bond formation possible, but why 4? Another question, this SCH bond angle in methane is 109.5 degree, but why not 90 degree? Because if p orbital undergo bond formation, then it should be 90 degree. Also, CH bond angle and CH bond length all in methane are identical. Why these all CH bonds are identical? In 1931, scientist Pauling came with a new idea that he explained that carbon has 2 valence electrons in the ground state electronic configuration, but when during bond formation it gets excited, then one electron from 2s orbital shift to the 2p orbital. Now we could see all there are 4 unpaired electrons possible in the excited state. Now in this condition, if each orbital get bond formation, then 4 bond formation possible, but there will have different, as S and P are different energy and different orbital shape, so they should form the different bond. But in methane all bonds are same, all bond angle also same. Then he told that these 4 unpaired electron get mixed, should get definitely mixed. Then after mixing it each form new orbital called hybrid orbital. So 4 new hybrid orbital form which have equal energy and also identical shape. Then only in methane each hydrogen, each CH bond length will be same, each SCH bond angle will be the same. And so now the problem is solved. Hooray! It's a one great relief. Now it can explain methane CH bond is 4 possible, all equal CH length, SCH bond angle is 1.109.5 degree, new hybrid orbital can be called sp3 as 1s and 3p get mixed and shape is tetrahedral. So here is one question for you. Scientist Pauling discovered this hybridization. So did he get any reward for that? If he get, which year he get that award? Now we'll discuss the types of hybridization. How many types of hybridization are possible for carbon? In ground state we could see this electronic configuration of carbon, and also in excited state this will be the electronic configuration of carbon. And if all means this S and all 3p mix, then after mixing it can produce the 4 hybrid orbital equal energy and identical shape. We could see this how this get mixed, and after mixing it form the sp3 hybrid orbital and looks its shape is tetrahedral and bond angle 109.5 degree. Each orbitals form the available for single bond. There is no extra orbitals remain left for pi bond. Now, in other two also possible, if among these 4 unpaired electrons, 1s and 2p get mixed, then 3 hybrid orbital generate. This looks how this happen. 1s 2p, so gives the sp2. This is trigonal planar shape or geometry. Bond angle, each bond angle are 120 degree and each orbitals are available for single bond. In these cases, as 1p orbital remain unhybridized, that are available for pi bonding. We could see another possibility. If 1s 1p are mixed, then sp hybrid orbital can form like this way. So this is the linear shape sp and bond angle 180 degree, and each these orbital are equal energy and available for single bond formation. Another, as 2p z unhybridized orbital left, these 2p are available for formation of 2 pi bond. Now, how to predict that hybridization? How we can predict that? If there is a sp3 hybrid orbital available, then each can form single bond like that way. So each orbital undergo chemical bond formation. So 4 sigma bond form, no pi orbital left for pi bond. The same way sp2 undergo chemical bond formation with 3 different atoms, and so 3 sigma bond is formed and 1 p orbital remain for 1 pi bond. In case of sp, 2 sigma bond is formed with the 2 different atoms and 2 pi orbital are left for pi bond, 2 pi bond. So simply we can see, we can predict if a carbon atom attached with the 4 single bond, then sp3. If 1 pi bond, then sp2. If carbon attached with this 2 pi bond or 1 triple bond, then it is sp hybridized. Now, can we predict the hybridization for heteroatom? So what is heteroatom? Mainly organic molecules are composed of carbon and hydrogen. Other than this, if atoms are present, like oxygen present in alcohol, ether and carbonic, and in alcohol oxygen here is sp3 because oxygen attached with all single bond. Ether also sp3 if oxygen attached with single bond. In carbonyl, oxygen attached with a double bond, so it is sp2. In case of nitrogen atom present in amine, all single bond sp3. Amine, this is single bond sp3, but it amine mainly show the resonance structure, so it's in the double bond form, that's why it is sp2. Cyanide, as nitrogen get attached to the triple bond, so it is sp. Isocyanate, this is the nitrogen attached with a double bond, so sp2. In case of sulfur containing compound like thiol, sulfide and thiocarbonyl, this is similarly all single bond sp3, sulfur attached with single bond sp3, sulfur attached with a double bond means sp2. Halide, in case of alkyl halide or halide, it's used the unhybridized p orbital. So halide don't need the hybridization. Now we have seen earlier that hybridization can be determined by valence bond theory, but is there any other theory there which can determine the hybridization? Yes, it is the VSEPR theory. If we know that Sn means steric number. Steric number 2 means the sp hybridization. Steric number 3 sp2 hybridization. If steric number 4, then it is sp3 hybridization. Steric numbers can be found if we know a atom attached with the number of how many sigma bonds are present in that atom or attached and number of lone pairs on that atom. Let's see this one example here. This is a on hydrocarbon. First, this carbon is attached with 1 2 and CC 1 sigma bond. So 3 sigma bond but no lone pair. That means steric number 3 plus 0. So 3 means sp2. These cases it is by VSEPR theory we can see the it attached with one single bond, this side one single bond, so 2 single bond and no lone pair means 2 plus 0 2, so sp. This cases this carbon attached with the 4 single bond means 4 sigma bond, number of sigma bond Sn equal to 4 plus no lone pair 0, so 4, so Sn4 means sp3. So by using VSEPR theory we can determine here also the same. Sn number steric number 3 plus 0 equal to 3 means sp2. Oxygen also Sn number 1 sigma bond plus 2 lone pairs, so steric number 3 means sp2. Here alcohol and thiol both cases 2 sigma bond plus 2 lone pair, so total steric number 4, that means sp3 hybridized. So but one thing is that, so which is very easily we can remember is that VSEPR is more reliable, means very easy to remember, or VSEPR. You can comment on that in comment section. Now come to the next part, importance of hybridization. So what is the importance of hybridization? Because it is we can easily predict the molecular shape, bond angle, geometry directly if we know the hybridization. If sp3 say, that means this all single bond, bond angle and also geometry like sp2 trigonal, planar, sp linear, easily we can find if we know the hybridization. Explain the equivalent bond like methane, all bonds are equal, and it explain the formation of double or triple bond. sp2 means 1 double bond, sp means 2 double bond, and it explain the bond length, strength, acidity. Basically how if it is sp3 say, then percentage of base character is 25, means the orbital is less tightly, orbital electron is less tightly bound by the nucleus, so bond is quite longer, strength is low and is quite basic in nature. And if it is like anionic, if it is sp2 it's moderate, if it is sp percentage of s character is 50 and electron are more tightly bound, electron by the nucleus, electron on their orbital, so bond is quite shorter in sp, and the proton attached to that carbon is acidic nature. Also it can explain the planarity, so sp3 means tetrahedral nature, means non-planar, sp2 trigonal, planar means planar, and sp means linear, that is planar definitely. Now we will move to another part, so limitation of hybridization. So in previous case we have seen there are so many importance of the hybridization, but is there any limitation that could not satisfy the hybridization or explain the hybridization? Yes, we could see that methane means the tetrahedral carbon here, and water, ammonia, all are sp3 hybridized, yet this carbon satisfy the bond angle 109.5 degree, where other cases the bond angle deviation happen, one for water 104 degree, 107 degree for ammonia. But why this deviation of bond angle? That means this is not, even it is all are sp3, but this is not the all sp3 hybridized orbital are not having the same bond angle, but it should be same bond angle according to the hybridization concept. That is gets failed. Second case, the its only application applicable to the covalent bond formation only, does not explain the formation of metallic or ionic bond. This hybridization concept, even it could not explain the delocalization or resonance, how this bond get resonance. So that could not explain the hybridization. In case of hypervalent molecules like SF6 PCl5, those cases these molecules are sp3d2 and sp3d hybridization have, but if you could see 1 3 6 6 orbitals mean 12 electrons, 5 orbitals means 10 electrons are there, means already they have expanded octet, but according to the BBT or hybridization it should only complete the octet. So these cases that exceeds the octet rule, so these are the, this cannot even explain. Even these are mixed, this s, p and d orbital to make this hybridization, but we could see that d is higher in orbital, higher orbital energy than other two. So how this mixing possible, that much energy difference? It's almost uh, quantum mathematically impossible. And so these are the things, this hybridization have limitation. The hybridization could not explain these things. Now then, why do we study hybridization? Actually, we have, there are other theory, those are accurate, but those are mathematically heavier. But if we know the hybridization, we can easily visualize the things. Like if one or anybody say sp3 hybridization, that means easily you can understand this structure, that all single bonds, bond angle and all these things. sp2 we can see on, definitely there is one double bond, sp means one triple bond or two double bond. So that immediately collect many information if we know the hybridization means bond, like bond nature, bond angle, bond length, bond strength and even geometry. So how interesting, isn't it? How powerful is that hybridization? So now we'll move to the shapes of molecule. So what is the shapes of molecule? We could see here two molecules, like one methane, another is formaldehyde. So to understand the shapes of molecule, we can say that the arrangement of atom in three-dimensional space is be the shape of molecules. So why this is important? This is important because it can determine the reactivity, polarity, boiling point, melting point and other biological activity. If we know the shapes of molecule, we can predict, we can correlate that. How to predict that molecular shape? Either it can be obtained by VSEPR theory or hybridization concept, but for organic molecule, hybridization are most useful. Like if say sp, then linear, sp2 trigonal planar, sp3 is the tetrahedral. So by determining shapes of molecule, which method is good, hybridization or VSEPR? Definitely the organic molecules are mainly composed of carbon, hydrogen. In these cases, there is no lone pair almost, so we can use the hybridization. These are easy, we have earlier used this, and only for compound or molecules which have the heteroatom like oxygen, nitrogen, they have lone pair, so that cases VSEPR theory gives the accurate result. We can look here two example we have shown here. This is methylamine. So by using hybridization concept, we can see nitrogen atom attached with the three, means all are single bond, and then according it is sp3 and tetrahedral, but according to the VSEPR theory, it's pyramidal the shape. Same with the methanol. By using the hybridization concept, all attached to the single bond. So sp3 hybridization means tetrahedral, but in VSEPR theory, it is the bend shape we can see. Now we will move to another interesting topic, that is planarity of organic molecules. So what is the planarity? If every atom of a molecule touch the sheet means plane, then it can be a planar molecule. Like this is benzene, this is ethylene. So molecules perfectly flat on the paper. How hybridization helps to determine planarity? If it is sp hybridized means shape linear, that means planar. If sp2 that is triangular planar shape, that means planar. If sp3 hybridization that is tetrahedral shape, that is means non-planar. So we can easily understand if we know the hybridization of atom, then local geometry or planarity we can understand. Let's culture with some example. We can cross check this. This is ethylene. So sp2 hybridization. All sp2 hybridization means planar. This anthracene molecule, all carbon sp2 hybrid is planar. This molecule also sp2 sp planar, and this molecule sp2 sp2 also planar. No sp3 means planar. This cases one sp3, other sp2 is there, so non-planar. Sp3 means non-planar. These ring are means aliphatic chain cycle, so sp3 carbon non-planar. These cases interestingly one sp2 sp and sp2 still it is non-planar. This is Allene and this is Cumulene, having the similar structure, but still one is planar, one is non-planar. We could see here this structure by model and look this video how this looks like at in plane, and you could see that the two double bond and another middle double bond are perpendicular to each other, whereas in these cases we could see the same, the it has two double bond and one is perpendicular to the other. This is Allene, this is Cumulene. So how we could then how to determine the planarity? One thing to remember that if there is the even number of double bond, this cases the Allene even number of double bond means non-planar. See this non-planar how it looks. And if there is a odd number of double bond, it is planar. Looks this Cumulene. If this conjugated double bond having the odd number of double bond, then it is planar. Now coming to the factors that affect the planarity: conjugation, aromatic stabilization, steric hindrance, and these are the factors which affects the planarity. If there is a conjugation, it tends to be planar. Aromatic compounds, all sp2 hybridized, are planar definitely, and this sometimes steric hindrance that affects the planarity means that not favors the planarity. Sometimes it's get out of plane these bonds, and hyperconjugation also helps for local planarity. This is called local planarity I am saying because that CH3 are tetrahedral shape, but this carbocation carbon is only in the plane with other three carbons. So whole molecule not planar. This is non-molecular planarity. This is the local planarity. But this methyl carbocation is planar. All atoms are touch the plane. The factors, the aromaticity near equal to conjugation that have much effect favoring the planarity than steric hindrance than hyperconjugation. So now up to this we have learned so many things, so many concepts. Next we will move to some previous year question discussion. These are mainly from joint entrance, NEET, and these some other examination in SEC, IIT, all those things. Let's see first. We will go for JEE. This is the question number 1. In Allene, the types of hybridization of carbon atoms are option given. This is Allene, so we could easily see by hybridization sp2 sp sp2. Then it will be sp sp2. Now there are no more question in JEE on this topic. Move to the NEET. Let's see question number 2. In the hydrocarbon, this one, the state of hybridization of 135 in the following sequence. So here one thing, 135, that sequence you have to maintain, otherwise you could do mistake. And 135, so sp triple bond, all single bond sp3, and 5 double bond sp2. So these are the answer. Question number 3, the state of hybridization of C2, C3, C5 and C6. So these are the options given. And now let's see. We have to C2, C3, find the C2 and C3. So 2 attached with triple bond sp, 3 all single bond sp3, sp3, then 5, 6, 5 double bond sp2 and sp3. So start with sp, sp3, sp2, sp3. Option 4. Now coming to the question number 4. Considering the state of hybridization of carbon atom, find out the molecule among the following which is linear. Linear means there is only one possibility if it is sp hybridization. So you could see among these alls, only this option 3, there is a triple bond. So sp hybridization, correct option in this one. Now question number 5. Which of the following organic molecule has same hybridization as its combustion product, that CO2? These are options given. Now let's see the combustion product CO2. This is linear, and carbon attached with the 2 double bond, that means sp hybridization. We could draw this ethane CH3CH3, ethine CH triple bond CH, ethene CH2 double bond CH2 and ethanol. So now this is both comparable because it is also triple bond, means sp hybridization all carbon. So correct option here is ethine. Now coming to the question number 6. So total number of pi bonds electrons in the following structure. So if we count the total number of double bond, we can easily get that answer. 1, 2, 3, 4, 4 double bonds means 8 pi electron. Correct option is this one. Now coming to the question number 7. The pair of electron in the given curve anion present in which of the following orbitals? These are the options given. Let's see. So as this carbon attached with the triple bond, that means this is sp hybridization. Now see how this carbon anion generation happens. Now this is the carbon, the ground state electronic configuration, and after sp hybridization, it's sp hybridization and 2 the unhybridized p orbitals remains for pi bond. So after sp hybridization, when it get bonded with 2 sigma bond formation with 2 different atoms, like one attached with one attached with one C bond, one single bond, and another attached with one proton, like this. Then when this proton get deprotonated, then this carbon ion will generate. So like that way, if get this deprotonated, proton will remove, but electrons remains in the same orbital. So that's why it's present this, the share of electrons are remains in the same orbital after proton abstraction. That means it's present in the sp orbital. So correct option here is the sp. Now Question number 8. Which of the following molecules are where the atoms are co-planar? These are the molecules. Here all atoms are sp2. This is biphenyl system, and means sp2 means that is all planar. This is sp3. Here also sp3 are there, and all this is sp3. You can see that their clear image. You can see this is flat on plane. This is not flat. This is also not flat. This is also not flat. You can see this here in the video. This molecule, the CH3 model video, here CH3, the carbon not touch the plane, even these few carbons are attached to the plane, and whereas this cases also we can see how this can look that all the from above all it looks the hexagon, but it's not touched the plane. It looks some chair like conformation, but from the top it is hexagon. So only biphenyl looks the planar all atoms, and if only it contains the ortho position some bulky group, that time some twisting happen, then planarity can happen, otherwise it is planar. Now question number 9. Which of the following molecules represent the order of hybridization sp2 sp2 sp sp? Left to right, this we have to keep in mind, otherwise you could do mistake. First sp2 sp2, then sp sp. See triple bond sp, this we can remove. This is CH3 means single bond, we can remove this option. Now among these two, so left to right, that means from here we are doing the right thing. This is sp2, this is also sp2. Now this is sp2 sp2, okay fine. Then this is sp, but this is sp2, so again sp. So sp2 sp2 sp sp. So here correct option is the option 2. Now coming to the question number 10. The number of sigma bonds and pi bonds and lone pair of electrons in pyridine respectively are. So we have drawn the pyridine structure here. But if we think like that, we can do mistake. We can have some mistake. We can see 1, 2, 3, 4, 5, 6 sigma bonds, 3 pi bonds, 1 lone pair. But we have to look pyridine like this. There is a CH bond, another 5 CH bonds. So total sigma bonds is 6 CC plus CH5 means 11 sigma bond, 3 pi bond, and 1 lone pair. So here correct option is the option 3. Now another question, question number 11, match list 1 and list 2. Although this is the partly question, the carbon atom which are sp3 hybridized among these allotropes of carbon, one coke, diamond, fluorine, graphite. You can see here coke, all these polyaromatic hydrocarbons are sheet attached, but they have interconnected via a single bond. In these cases, the carbon is sp3 hybridized, only few cases, maximum are sp2. But in case of diamond, all the atom connected only by a single bond, means diamond are fully, all carbon are sp3. Fluorine, all carbon are sp2 hybridized atom. In case of graphite, these are the polyaromatic hydrocarbons. The aromatic ring, polyaromatic ring are get stacked one by one. There is no single bond or interconnected bond in between them, so it all fully sp2 hybrid. So here correct option is the diamond only. Now coming to the another question number 12. Here match list 1 with the list 2. In the list 1 molecule name given, in the list 2 the types of bond and between the two carbon atoms, that we have to only consider carbon atom only, carbon carbon bond. Now first one is ethane. We draw the ethane molecule. You would see that so carbon carbon one single bond is there. Then for ethane there is only one sigma bond. In case of ethene, carbon carbon one sigma 1 pi bond is there, ethene. So then we can see this ethene 1 sigma and 1 pi bond. Now we will move to the ethane. So this cases in between carbon carbon 1 sigma and 2 pi is there, 2 pi bond. So we could see ethane 1 sigma and 2 pi bond that correlate. Now for carbon molecule C2, this is the question from the one topic, that MOT, molecular orbital theory concept. Here from this diagram MO, we could see that only 2 pi orbital are containing the bonding electron. So this is the 2 pi bonds. If we even don't know the MOT, but the rest answer, that's why I keep it last, we can make this. So now another question is the match the list 1 with list 2. So first one C2H4, we have drawn C2H4, this is ethene, and so now ethene, so what is the bonds are there? 1 2 3 4 5 sigma bonds and 1 pi bond is there. So this is 5 sigma 1 pi related to C2H4. For C2H2, 1 2 3 sigma and 2 pi bond. So the 3 sigma and 2 pi related to C2H2, and methane all are sigma bond, 4 sigma bond. So this 4 sigma bond related to CH4, and for this NH3, that 3 sigma bond and 1 lone pair that related to NH3. Now we'll move to the another exam question, that is National Standard Examination in Chemistry NSEC. The question number 14 overall, the molecule in which all atoms are not coplanar. These molecules given, but which cases all atoms are not coplanar. We could see that all are sp2, these two, and in middle or sp. These cases all single bond sp3, sp. As it is sp3, that means not planar. First see that here coplanar when all sp or sp2, that is common, and avoid coplanarity when it is sp3 or even number of cumulative double bond. We could see here 1 2 3, this is cumulative double bond, but also it is even number. This case this is isolated conjugated double bond, and then the answer is this is sp3 hybridized, not coplanar, and this could be this also, as this is only even number of conjugated double bond. Now another question, the hybridization of sulfur in CH3SH molecule, methanethiol. Options are given, we need to find out the hybridization. We could see here, as sulfur attached with all single bond, it is the sp3 hybridized. More details we can see this electronic configuration of sulfur, and after hybridization it looks like this sp3 hybridization after mixing. So there are two non-bonding electron part are present. After bond formation, these two unpaired electrons are remain in the sulfur, which are available for single bond formation. Here we could see, and another two non-bonding electron pair are there as a lone pair. So overall this is sp3 hybridized. Correct option is this one. Now coming to the question number 16, which of the following compounds contain maximum number of sp2 hybridized carbon atom? Here options given. First we have to draw this molecule, only then we can find out. First one 1,4-cyclohexadiene, this one, then 2,5-dimethyl 2,3,4-hexatriene, 2,5-dimethyl 2,3,4-hexatriene, this is benzaldehyde, and this is 1,1-diallyl. This function is red color allyl group, and this color is vinyl group, 3,3-divinyl cyclopentane. Now the question is maximum number of sp2 hybridized carbon atom, means if there is a one double bond, then it have two sp2 carbon. So in this cases, two double bond means 4 sp2 carbon. This cases you could see that 1 2 3 double bond are there, means yet 1 2 3 4 but this last two are sp2, in between middle two are sp. So only two sp2. This cases 1 2 3 4 5 6 6 sp2 7 sp2 this earlier, and this cases 4 double bond means 8 sp2 1 2 3 4 5 6 7 8 8 sp2 hybridized. So maximum answer is this one, 8 maximum number sp2 hybridized carbon atom. Now question number 17, the compound not having the planar molecular configuration, which cases? So about chlorobromido when it is sp3 or even number of cumulative double bond, that means we can see here that is all sp2, this is sp2 sp, this is 1 2 3, 2 are sp2 and middle on sp, but as it is even number, so this is the right answer. This is non-planar. This is odd number, this is planar. Now coming to the another exam question, that is NEST National Entrance Screening Test. Question number 18. In this molecule, the state of hybridization of C1 and C2 atoms are respectively. Option are given. Look this. C1, we have to need to know the naming of this molecules, means numbering, functionality, how the priority of function will happen. So 1 2 3 4, 1 is double bond attached, so sp2, and 2 attached with 2 double bond, so sp. So correct option here is the sp2 sp. Now the another question is from the exam CUET UG Common University Entrance Test for undergraduate. Now the question is, in amines nitrogen atom A and B, nitrogen atom is A, it is B hybridized and making the geometry of amines as C. Then A, B, C respectively are, these are the options we have to found out what. First let's do this problem, do this solution. Nitrogen atom, this is the ground state configuration of nitrogen, 2s2 2p3. So as the outer electronic valence electronic configuration, it contains the 3 ampere electrons, so it is trivalent. So let's remove these two options, only we can consider 1 and 3. If after hybridization this 3 and S hybridized, it will be sp3 hybridized, where 1 in non-bonding electron remains a non-pair, another 3 unpaired electron gets bonding with another 3 group. One is 2 is with hydrogen, one is in group another atom of any group. So it is sp3 hybridized. Looks, this is amine, and we could see that how this amine structure looks like by model representation. It looks like a pyramid. So here correct option is the option 3, trivalent sp3 and pyramidal. Now question number 20, nitrogen atomic amines is trivalent and possess an unset pair of electrons. The geometry of trimethylamine, this is the similar like question of previous. Option are given, you have to found the geometry. So you could see that this is trimethylamine and it looks like pyramidal geometry. So answer is the option 2. Now we have choose some question from NCERT book. The question number 21, how many sigma and pi bonds are present in each of the following molecules? So you could see that this molecule, we can count the atoms as one bond there in between two atoms. So we can count the atom first, then we can find 1 2 3 4 5 6 7 and 8 8 3 11. So 11 atoms means 10 sigma bond definitely there, and you could see here 2 pi bond and 3 pi bond, so 10 and 3. These cases 3 4 5 6 7 so 10 atoms means 9 sigma bonds and 2 pi bonds here, so 9 and 2. Now question number 22, what is the type of hybridization of each carbon in the following compounds? This is we can see the CH3Cl, CH3, this sp3 hybridization, all attached to single bond. So sp3, this cases CH3 means sp3, CO, sp2, and this cases CH3 means sp3 and Cn triple bond. So sp, this cases we can see here CHO, this sp2 carbon, and we could see here CH3 means sp3, C double bond means sp2, and Cn triple bond means sp. Now 23. What is the state of hybridization of carbon in the following compounds and shape of each molecules? So this H2CO, this is sp2, this all single bond sp3, and this case is triple bond means sp. Now NCERT exercise question number 24. What are the hybridization state of each carbon atom in the following compounds? You could see this sp2 sp and double bond means sp2, triple bond sp, and the same here sp3 sp2 as double bond, and in case of benzene C6H6 all are sp2 hybridized. Another question, indicate the sigma and pi bonds in the following molecules. C6H6 means benzene, but we need to consider the CH bonds here, all these 6 corner. So total sigma bonds is 6 plus 6, 12, and pi bonds are here 3. In case of cyclohexane, 6 CC bond in the chain and another CH is corner 2. So total 18 sigma bond, CH2Cl2 4 sigma bonds, no pi bond. These cases we could see there 2, 3, 4, and another 2 6 sigma bonds and 2 pi bonds. This cases nitromethane, here is 3, 4, 5, 6 sigma bonds on pi bond. These cases we could see here 1, 2, 3, 4, 5, and 3, 8 sigma bonds and on pi bonds. Another question, the organic compound. Here we have to find the pair of hybridized orbital involved for the C2C3 bond, but we need to know the numbering of this molecule according to the priority of function group. Then we could do the right thing. Otherwise, even we know that hybridization, we could do mistake. This is the right way of giving the numbering 1, 2, 3, 4, 5, 6, and this is the wrong. If we give this way, then we could do mistake here sp2 sp3, but this is the right way. This is the sp and sp3, so this is the right one. Now there are other some practice set. Let's do that. Question number 27, hybridization and geometry of each carbon atom in C2H4. We know that C2H4 here, C2H4 means ethylene here, so we could do that. sp2 trigonal planar, we can see here this how it looks like the planar structure. Hybridization and bond angle of each carbon atom of acetylene. This is the structure of acetylene, and we could see this. This is linear and sp hybridized of carbon 180 degree option. Looks this video how it looks like. The structure are linear. This are on linear plane. Question number 29. Which of the compound is completely planar? So methane, ethane, ethylene, and cyclohexane. Planar means if it is sp and sp2 hybridized. We know that here the N means sp3 hybridized, means this is the simple hydrocarbon. N means that is unsaturated hydrocarbon. N means saturated hydrocarbon. N means it is sp2. So this case is ethylene means it is only the sp2 and planar. Now question number 30. So what is the percentage of s character in sp3 and sp hybrid orbital? We could see the sp3 1s and 3p, that overall 100%, so it contains only 25% s character and 75% p character. In case of sp, total 100%, so S is 50% and P is 50%. So here correct option is the here 25 and 50% of S character. Question number 31. So what is the CC bond angle in benzene? All are sp2 hybridized carbon in benzene. sp2 hybridized means we know the bond angle is definitely 120 degree. Now question number 32. Which molecule contains both sp and sp3 hybridized carbon? Methane, propane, benzene and propane is given. N means saturated hydrocarbon, sp3 in sp2, and ine means it is sp hybridized. Now draw this molecule. Methane all single bonds, propane all single bonds, saturated hydrocarbon, benzene all are sp2 hybridized, and propane this cases we can draw this and see the two carbon atom are sp and another is sp3, third one. So here correct option is the propane. Now question number 33. What is the hybridization of oxygen in carbonyl? Here the options given. You could see as oxygen attached with a double bond, so definitely it is the sp2. Now question number 34. What is the hybridization of carbon in carbocation? Means methyl carbocation CH3 plus. Options are given. We need to know that how this carbocation is generated. Either it from alkyl halide or from alcohol where carbon is sp3 hybridized. During formation of this carbocation, their hydroxyl group left from alcohol, their hydroxyl group or leaving group takes the electron from this carbon. How you see this? This is sp3 hybridized. So that hydroxyl oxygen which shares with the electron carbon, that totally all electron it takes out from this orbital, so it remains the vacant. Now to minimize the repulsion, it gets unhybridized p orbital. So carbocation are sp2 hybridized. So the correct option is the sp2. Question number 35. What is the hybridization of carbon in carbon free radical? Options are given. It's the similar like question. Let's say how generation of free radical. Here if this methane undergo homolytic cleavage gives this free radical. Now the one electron which gets shared, it takes the proton that takes that electron as well. So one unpaired electron left in that orbital. But we could see that if it is present in the sp3 hybrid orbital, see the electronic repulsion, it is the greater repulsion. But if this unpaired electron remains in the this unhybridized p orbital, we could see this it looks sp2 where the bond angle or orbital angle is more, so there is a less repulsion. That's why it's splitted as unhybridized p orbitals, electron remains there, and the carbon in this free radical are sp2 hybridized. So correct option is the sp2. Now question number 36. What is the hybridization of carbon and cyclopropane? So propane, cyclopropane all saturated hydrocarbon, but this is more strained molecule, so all bonds are not this straight line. It looks like it forms banana bonds, but all these 4 bonds attached with the carbon, so it is sp3 hybridization. And question number 37. The CH bonds acidity is found maximum in which of the compounds? Benzene, methane, acetylene and ethyl. So acidity more in sp cases than sp2 than sp3. Benzene all sp2, methane sp3, this is sp2 to carbon, and this acetylene are sp hybridized carbon attached with proton, so it is more acidic as the orbital electrons are tightly bound by the nucleus of carbon. So correct option here acetylene. Now question number 38. Which among the following compounds has the shortest CC bond? Option given. Shortest CC bond when there is a sp, then sp2, then sp3, In benzene, all sp2. In ethane, there is a 2 sp carbon having triple bond, so shortest bond. This is saturated, and this is the sp2 carbon only, ethylene. So here correct option is the ethane, this one. Now question number 39, the number of sp2 hybridized carbon atom in naphthalene is how many? So we could see that naphthalene structure, all atoms are sp2 hybridized attached with a double bond. So total 6, 7, 8, 9, 10. 10 sp2 hybridized carbon atom are there. Correct option is the 10. Which of the following has all three sp, sp2, sp3 hybridization? The option given, we need to draw the structure only, then we could find the each hybridization of carbon. This one but 3 ion 2 1, 1 2 1 and 3 ion. This is the acetopenone. This is cyclopropene 1 1 2 in, and this one but 3 in and 1 1 2 3 4 3 in and 1 ion. Now we could see that this cases sp sp2 sp3, this one, yes, this is all sp2 sp2 sp3, there is no sp. This cases sp2 sp2 all, and this cases sp2 sp2 sp sp, but no sp3. So only this one, means this one is the right answer. This cases all three different hybridization are there. Now this is the case where question number, where the greater S character leads to the which option? Option 1 is the longer bond, lower electronegativity of carbon, and then shorter or stronger bond and no effect. So here is the greater S character means the sp only, means triple bond. So correct option here is the shorter and stronger bond. Now finally, thanks for watching. Please subscribe. Your subscription motivate me to upload more content like this. Get in touch. We will meet in our next video. Thank you guys.